Hello everyone, we are from group 3. Today in this project we are going to learn about assemble learning and clustering techniques that we are using in this data set. Here first we are importing the required packages like NumPy, Pandas as we have seen in the earlier assignments. And the data set which consists of the financial payments. Can you please scroll down? Here in the data set, we can see that there are like 6 lakh records that represents the financial transactions. Here we can see the type of payments like the transfer payment, cash out payment, and the amount and the original balance, new balance, and the data set, whether it's a fraud one or the flagger ones, etc. Scroll down. Here the step column serves as a numerical identifier, and the transfer payment etc encompasses the transactions, and also the amount describes the transaction that is offering a crucial dimension for understanding the financial magnitude. And the data set is inherently valuable for studying and addressing issues related to financial activities, that is offering a set of features that can be leveraged for analytical and predictive purposes. And here, whether it's a fraud or a EASE flag fraud indicators, and the main problem description is the data set appears to be the financial transactions that may be possibly the banking or the financial institution. The primary challenge is the identification of fraud transactions that indicating the fraud column. And the main goal of this project is to employ machine learning techniques, especially focusing on the assemble learning and clustering to gain understanding of these fraud transactions within the financial data set that we have seen in this project. By analyzing this data, the main aim is to identify and qualify the key factors that contribute to fraudulent activities. This analysis is not only intended to provide the actionable insights for financial institutions that enhance the fraud detection mechanism, but also to contribute the development of effective strategies and interventions for minimizing these fraud transactions. Ultimately, our main project goal is to improve all this overall securities and the reliability of financial transactions, ensuring the protection of both the customers and the financial system. Here we have seen the data information of that data set. Here we can see all the columns and the data type like float, int, and the data. Can you please scroll down? And next, the data description. Here we can see all the count, mean, STD, etc. of the data set, the average amount, balances, destination balances, fraud flags, etc. This is a statistical overview of the complete data set, which we can see here. By this we can analyze the data in a more depth way of understanding the patterns and its characteristics. Scroll down. And the data dot is null and the sum, we can see the columns and all the is null values, or everything is 0. And then the duplicates of that data is represented in this output. Here we can see the data set contains financial transaction records with 11 columns, including the step representing the time set, type indicating the transaction type, and then the transaction is fraudulent, 1 for S and 0 for no, and EASE flag fraud, mapped flag fraudulent transaction, same as 1 for S and 0 for no. The data set captures a range of transactions, including the payments, transfer, and cash outs, with some instances that are mapped as fraud. Here the figure, can you please scroll down? Here the figure describes the payment types. We can see the values and the figure size as 10,7. The plot describes the data. Can you please scroll down? The provided scale ranges from 0.00 to 0.35, indicating a progression of values. The corresponding transaction types include the cash out payment, cash in transfer, and the debit. Each type is associated with a specific value on the scale, with payments that is being on the low end and the cash out. And the debit is associated with these ones. And the cash in and transfer fall between these extremes, like 0.20 and 0.25 respectively, and the debit is associated between the values of 0.10. This scale appears to represent a relative measure of weight assigned to each transaction type with a given content. And here we are printing the percentage of frauds and no frauds. Here we can see the no frauds percentage is 99.87 and the frauds percentage is 0.12. Can you please scroll upwards? The given code calculates the percentage of these. The output indicates that approximately 99.87% of the transactions are classified as non-fraud, while the 0.3%, 13% is identified as fraud ones. And when it comes to the imbalanced data, can you please scroll down? Downwards. Upwards. The imbalanced data set data.drop of the ease fraud, the name, origin, and the name of these columns where the axis is equals to 1 and the in place is equals to true. Here we can see the plot like correlation data is equals to data.copy and the data type, and the figure 10,12, the correlation data heat map. In this figure, we can see all the columns with the percentages and their values, like from 0.02, scroll upwards. Downwards. The figure 2, 1. Here we can see all the percentages of the columns. Scroll down. By this figure, we can say that there is no correlation between columns. Downwards. And the data dot head, we are going to take the output of the data set. Again, we can see the description and the tables of the data set. When it comes to the data preprocessing, here we are using the sklearn by importing the rebus scalar and one hot encoder. We can see the tables here of all the columns in the data set. The provided code demonstrates the use of robust scalar from scikit-learn to scale the numerical features of data frame named data F. The scaling is performed to influence the outliers. After scaling, the transformed data is stored in new data frame, which is data SC. The resulting data frame displays the scale values of the features, including all the columns like step, amount, old balance, etc. The scale values indicate the relative positions of the data points within each feature, preserving the robustness against extreme values. And the description of the data is represented here. The count, mean, STD, minimum, etc. of the new data. And then the data training, model training. We are taking X is equals to fraud data dot drop, and Y is equals to fraud data is fraud. X is equals to dot information. Here we can see all the information of the data set, the columns and the count and the data type, and the Y information of the is fraud data. Scroll down. We are training, testing the X and Y data sets. When it comes to the X train data, here the table is represented here. We can see all the data here with 4953 rows and 10 columns. Scroll down. And the Y train data and the ensembles classifiers. Here we are importing the random forest classifier, gradient boosting classifier, logistic regression, importing voting classifiers, and then we are importing train test split, importing the pipeline, robust scalar, column scalar, accuracy score, importing the cross value score, etc., creating the ensemble classifiers, voting them, the pipe 1, pipe 2, and pipe 3 pipelines, defining the classifier labels like random forest, gradient boosting, and ADA boost, printing the headers like tenfold cross validation, looping through each pipeline and label by performing cross validation and obtaining the ROC scores like X is equals to X train and Y is equals to Y train, CV is equals to 10, and scoring is equals to ROC, and then printing the mean and standard deviation of these ROC scores. Here we can see the output of these values, the random forest, gradient boosting, and ADA boost. The creation and evaluation of a ensemble classifier using a voting classifier with the 3 base classifiers. Each base classifier is individually encapsulating in a pipeline that includes a robust scalar for feature scaling. This classifier is evaluated using a tenfold cross classifier, and the effectiveness of the ensembled approach in combining the strengths of diverse classifiers for improved overall performance. Majority voting classifier. The ensemble scores is equals to score value score. This code represents the resulting mean and standard deviation of ROC scores that indicate the exceptional performance with average ROC of 1 and 0 standard deviation that encompasses the robust predictive accuracy and the consistency of majority voting ensemble character of the training data set. From here, my friend Karthik will continue.
Mhm. Mhm.
Karthik, that's okay. You can continue from this.
Okay. Thank you, Shravya. Uh, as usual, Shravya explained those all things about the ROC and ensemble classifiers. Now we are taking the ensemble classifiers here and adding the different testing process here, like finding the exact accuracy, precision, recall, and all things. We are printing the evaluation matrix like using these all to ROS accuracy, precision, recall, and defense score to create a confusion matrix. So we're getting the output here as 99.99%, 0.99 precision, recall, defense score as output. So the confusion matrix is, can see the columns and logs over there. These ensemble classifiers demonstrate the strong performance of ROC curves, and achieving 0.99 is not a bad at all. It's a good positive accuracy we found. And also um, the hypermeter of classifiers is separately as a group. Here we are separating these all as a group, so you can see the grid search, and you can see the estimators of learning. We are doing the hypermeter tuning for this ensemble because it gives a better accuracy and also best result in the end of the final output. So using these all hyperparameter tuning classifiers like hyperparameter random forest gradient boosting and also the ensembles, they're getting the best results here by using this hyperparameter. We're not going to be run right now because it takes a couple of hours to run. And these optical hyperparameters are boosting the accuracy and gives the best results at the data set which we collected previously. Coming to this prediction and evolution of these ensembles, we did just prediction and predict the model, and we run the different scores here with the confusion matrix, and also we got best results as accuracy 0.99 and best results also. And here you can see the receiver obtaining ROC curve. It is in the gradient boosting random forest taking the all ensembles here, ensemble classifiers. And after that, we doing the k-means clustering is the main important stuff in that. K-means clustering, we use it for scikit-learn preprocessing and also for the other purpose. Here, the data visualization shows that 14 data points are results centroids. The clustering algorithm also to pattern the perfect distinct groups of the clusters. It means the centroids represent the center of each other. And here you can see the centroids are only four here. So now we're using the elbow method in k-means clustering. Elbow method is nothing but it's an optimal k clustering, like how the determine the optimal number of clusters in the K k-mean algorithm, and also the x-axis represents here the within the square and also number of customers K. So the leading the gradual action on some of the square distance between how many gradients is working. This is Silhouette separation between the clusters and also deviation rule. We added extra for this, and we given a plot in Davis Boolean for each cluster, like how the Davis Boolean index plots, and also gives the average Davis Boolean from the cluster, and also the Boolean index. Here you can see the results as a scoping from 0 to 0.8. And this plots displays that Davis Boolean index are helping to identify the optimal number of clusters and selecting the approximately 4.5 clusters like that. The average is 4.5. And here you can see the another number of clusters k-mean algorithm. Here the centroids are different here, which indicates a symbol. And the we collecting couple of clusters here, like light green, orange, blue. We're using the centroids here and finding the best result of label cluster one, cluster two, cluster three. Like across each cluster, it represents the centroids as the main values, like that. This is conducting between two good clustering and bad clustering. Like good clustering, how many centroids is there, how many working perfectly in the k-mean algorithm, like different colors we added. You can see the cluster one, cluster two, and cluster four and centroids here. Here also less centroids here, but the bad clustering is showing the most centroids because the centroids are uh, regular, not for the bad clustering. So it's showing the vulnerable centroid, meaning that not accurately represents the tendencies and also corresponding to the main. So finally, the result is in our conclusion is the random forest gradient boosting all algorithms that were taken for the finding the ROC best AUC score and also giving the best results of accuracy, precision. and of FM scores also. Moreover, the evaluation metrics indicated that these all centroids and these all ensemble classifiers are mostly used in this accurately identifying the transition and the hypermeter tuning process further optimized as a overall success and also ensembling the k-means clustering. These both are mainly used in our machine language project for the approaching the fraud detections and also showcasing some ability to our platform. So that's all from our end. Our team is supported very well. Thank you all guys. Uh, have a good one.